In this session, we look at the input signals other than step and ramps. However, those can be expressed as summation of steps or summation of ramps or summation of both steps and ramps. So let's first look at the pulse signal here. So we have for this signal, for time less than 0, we have the value 0.5, and between 0 and 10, we have the value at 1.5, and after 10, it again becomes 0.5. So if we express it in the divisional form, that is subtract the value of the signal before time 0, that's why we're using the notation 0 negative here. So u prime t, it's 0, so subtract this value 0.5 there, so it will be 0 for t less than 0, 1 for t between 0 and 10, and 0 again for t greater than 10. Okay. Now, how to express this signal in terms of two steps? To do that, let's look at, if this is my 0 value for the signal, to express u prime t, consider that this is my time 0. So at time 0, it becomes 1. So if we add a step there of value 1, now this step has a value of 1 for t greater than all t greater than 0. Now you see that the signal comes back to 0 when t is again 10. So time 10, we need to do something to make this to 0 again. So to do it, you can simply have another step which has a value of -1. So now you see that if you really add these two, we'll end up getting the original signal there. So if we express the original signal now, we'll have, so this for the original signal, if this is the 0 value, so at 0 it becomes 1, it continues to 1. However, now if we add these two, we'll have something like this. Now, in terms of mathematical equation, how to express this, we'll have u prime t, which is this signal, the summation of this number 1 and number 2. So for number 1, it will be 1 delta 0 using this notation, and then for number 2, it's -1 delta 10. So now to get the Laplace domain expression for this, we'll have us, the summation of a step, is 1 over s. So the Laplace transformation of a constant is simply the constant over s. And again, this is -1 over s. However, we have a delay term here, so it will be expressed into -10s. As the Laplace transformation of the delay is simply exponential of -10s. So thus we express the signal in terms of the sum of two signals and then get the Laplace domain expression for the same. Now let's look at the expression for this signal now. Now for this case, we can express the signal. So before 0, the value of the signal is 1. And then after 0, if you look at the slope of the line, it's 1 over 5, that's 0.2. So it becomes 1 plus 0.2 t for t between 0 and 5. And then the value becomes constant at 2 for t greater than 5. Okay. So in the divisional form of the signal, we can write then u prime t, just subtract the value before time 0. So it will be 0 for t less than 0, and it will be 0.2 t for t between 0 and 5, and again 1 for t greater than equals 5. Now how to express this as a summation of either steps or ramps? or both. Now if you look at the signal, so if you consider this to at 0 time, so this u prime t signal start to, it's 0 before time 0 and start to go up. Now, if you express this as a ramp, the ramp signal continues to increase beyond time 5. So at time 5, we need to have something that will balance this signal, meaning that the original signal becomes constant here at time 5, so you have to add something or remove something to make it constant. And if you look at that, you can see that if you have a negative ramp with the same slope however negative, so you see that at time 5, whatever the value after time 5, whatever the value of this signal is the same as this one. However, this has got a positive value, this has got a negative value, so they cancels out, and it will remain constant whatever the value was at time 5. So you get the original signal there, which is represented as, so this is at time 0, so it's going up. So at time 5, it becomes constant at a value 1, it remains there. So you see that after this time 5, for this signal, whatever value of this signal has beyond 0, that cancelled out by this negative signal over here. So eventually you get the signal that we are looking at. So mathematically, it will be u prime t. So this is a ramp, which can be represented with the slope between 0.2. So t delta 0. Now this is a negative ramp, again 0.2 slope. However, we can express it starts at t at time 5, so it will be t minus 5, and then delta 5 to indicate that before 5 it's 0. Okay. Now if we express this in the Laplace domain, you will have 0.2 over s squared. This one 0.2 over s squared. However, there is a delay time, it will be minus 5s. So this is the Laplace domain expression for that signal.